Hello, this is me, SP Hero Smith. Today is devlog day 2, trying to get go back from where we left off on the rewrite. So uh oh, I don't need an introduction. Let's get into the code. Um I have it here actually. So I'm gonna put CD slash and oh, what the heck? And ls then okay, we're on new base. Make and combine everything. It takes time. Right, and ls um, hello world from Crafty Ball. Okay, cool. Let's start up Emacs and go back where we were. Or actually, instead of this, just minimize. Okay, I have this. Then cxcd project slash wire. Go into program and there's flags.cpp and flags.h. We open up flags.h, bx5 to p. Emacs is actually, let me check out some themes. I actually have like custom I can put spread about. I made a green theme. See what that looks like. Ooh. Is it good? I'm not sure. It's it looks weird. It looks very weird. I think I'll keep it finger finger dot. Okay, yeah, I had the wombat face. Alright, I'll see how things say. Okay. Get back into writing some code here. Then this. Oh, oh yeah. Take this over here. Nice. So we have some flags here. Nothing's changed much. We just want to something. I had some ideas here. Rule setting const are the same exactly the best. I had an idea. What if we write a template class? What if we write a template class? It program. Oh, that's okay. We're gonna touch source or actually no, settings and touch settings. We have now these two files, settings.h and settings.cpp. But minimize. Okay. Then we want tx52 here. Oh, look at that! Look at that bird. It's cuckoo, 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 cuckoo. Okay. TXCF. Okay. H. Then we do if and def H line H diff. Then we do template. Okay. Template. Oh, it highlights template. Oh, look at that. Ain't that interesting? Mode. Maybe it would be registered as C++ if we... Yeah, okay. Let's open up a trill. I have a trill here. Let me open up a file. Save you the... Alright, I am back. We have the book here. Let's go to the standard library. Actually no. Perhaps where was templates. An introduction, a simple string template. Types as parameters. C++ template mechanism. Recipe fit with form of programming template for super values. Attended control properties. Of an inheritance. Open types acceptable number of template arguments. The composition offered by templates is typesafe. No object can impose it. Distributed definition. A template's requirement has arguments cannot be simply incorrectly stated in code. Every major standard language process, standard of the template string, illustrating whether complete with not removed from. So, the key operations, string comparison, it's a library factor, rich source for example of template and programming, maybe a line for control. Okay. This is a big one, since templates are like really important. And using class templates are introduced to the simple string template. So template type names to string of characters. Subscripting concatenation and comparison that we usually associate with the notion of a string. Yeah. Okay. C specifies that a template is being declared and that a type argument C will be used in the declaration. Second level type name. Template, independent from template class C. Either case, C is a type name, it will be the name of a class. Mathematicians will recognize type name C as part of a function, so all C, all such a C will be the type. C is a type. Okay. Character. Nice. Defining a template. Unless generated from a class template as a perfectly organized class. This is not defining against our multiple. Lead to a decrease of code generated because code can mean different kind of class template and generated different number of units. In addition to class templates, string class templates. So, yes. So you can make special constructors for different types. interesting stuff, I think. Right, so let's write template type name, type name type. There's any type name type, right? Then, okay, this is a settings type, or yeah, any type. Then we can write class setting, right? Public setting, and then that setting will have to take a type default. It'll take a type default. Actually, let's make a private member here. At the end, private member. We'll write a private member type data. So that's the type of default value. Then after that, for this setting, I also want to create a table of oh wow, look at that. We have these. So we want a default value, and I also want with that template. I'll look later. Template instantiation. Okay, it's just a regular class. So, I wonder about like STL containers. Standard library overview. So, okay, containers can be categorized like both sequence containers, half open sequences of elements. Associative containers provide associative lookup based on a key. I want to use an associative container. Sequence containers, ordered associative containers, an ordered map from K to V of a sequence of K to V. An ordered map from K to V duplicate keys allowed an ordered set of K, ordered set of duplicate keys duplicate keys allowed. These containers are usually implemented as balanced binary trees, red black trees. Okay, so unordered map K to V equal to keys allowed an unordered set of K. So unordered map KVHEA. I want to make an STD map. So map from K, B, C, and A. Container representation. This is a vector, a list. A map is a balanced tree of nodes pointing to key value pairs. Right, that's nice. Element requirements. Element of a container and object can be of a type that allows the container implementation to copy, move it, and to swap elements. Nice. Here's comparisons. There's other relational operations. So the operations for a map are the key compare, key comp, and value comp associated container. So the map is O log n time. Not bad, not bad. Other entries are measures of the efficiency of the operation. Data notations. Member types, so a volume type, hash, constructors, destructors, and assignments. Size and a capacity. Iterators. Element access. This is for element. So list operations, other operations, container. So we have vector, vector indoors, vector indoors, vector anyways, list, associative containers. Lookup based on keys determine two variants. Ordering criterion. Unordered based on a hash method. They simply implemented a hash table with link overflow. Sequences of key values for sets, match without values. This is the data. Key is also the value. Match and sets for the ordered or unordered come to variant. Plain, sets and match for the unique entry for each key. Multi, sets and match for multiple entries can exist for each key. The name of an associate container indicates in which place it is. Set LMAP plain, unordered plain, multi. Let's also the associate containers are map or multi-map. There's unordered map. I want to make an unordered map. So arguments and number types or map. Okay. Zero company ordered. Unordered. The order of the insertion. So, constructing unordered maps. So T, the type name, hash is hash of key. Predicate is equal to key. Unordered map X uses hash X for hashing and equal to X. So to write a map like this, we want template type name type, right? Then we want a class setting that takes public and private data, saying something like hold up, a key. Constructors KTHE. So a key, a type, a hash, a predicate, or equal to key, an allocator. STD allocator, STD curriculum, Q2. So the only thing we need to put in is a key and a type. The template of type name key or type name type. So really a setting, and you need a type first of all. Then secondly, we actually no, there's nothing else. It's just a string, right? I don't know. Do we also write the string as a template? Are we feeling that risky or abstract? Nah, not really. So there's a type for default value. Then we need an std unordered map for a key being what std string with std string, and the key, the value being right. That's what we're writing. We need a map of unordered string in this. We're going to call this table. And then we can write, there's some data here. This is the actual data. Then we do the std unordered std string type table. So this is our table. So we want our default value and then the table. That's the setting. Then we want an access function, so a function that returns type called access. It does nothing basically. Then we want to make a void function called set. No, we only have one accessor, a selector. The mutator should be just okay, so a private function called set. So a private method called void set and type. This is type access. Then there's void sys std string, and then type. We pass the string by reference, maybe. Okay, so const std string reference, right? And then we also, that's it. That's all we're gonna do. That's gonna access and then manage. So there's manage that takes this. There's a private one that says void, and then there's a type returning one that is type search. On search, we'll just look for const std from this. So this one will just set the search of the string. Very easy, right? Very simple. Only really 4 functions. That's it. That's all that is. We also don't need to access the table at any time since we're only setting it once. So constructing unordered maps has a lot of template argument and member type aliases to map. Using key type, the value type, std pair const key, map type up. So how would we use an ordered associative container? Member types for map. So you need a key, a t, compare, less of t, and the allocator pair const key. That's if you want them. These are the constructors mentioned in this. The associative containers have constructors along with the programmer to specify a comparator. Construct M to use the comparator CMP and the allocator A. Explicit in A, like such. For example, a string, pair, coordinate, and coordinate. Then the associative containers are very of insertion and lookup operations. The search is D is a reference to the element with key K. If K is not found, an out of range is thrown only for map and unordered map. So C at that. So D is a reference to the element with K. Okay. So B has to be of type K.map type is inserted into C only for fine. C points to the first element with CK CN. Lower bound or upper bound. There's insert, there's C in place. Regardless, we do make a map here, and then this map is basically just a series of keys together. We could make a type def. We could make a type def here. So let's do type def std unordered underscore map std string type table. Actually, we'll just call this table, and then have one called table of values that it can be set as. Can we make a type def a member? Do we need to make a type def a member? We'll do it. Let's do it. Why not, guys? Okay, type def, then that's table. I'm going to make it a lot easier. A lot more concise. Table, and then so then given the table. That's just type, so it's string. And that's it. That's all our settings are. This is our settings function. Now we'll do cx2. And then in cx2 we do settings. Include then I include settings.h, and then I write some of the functions here. Then the default setting, which takes nothing. That's it, right? Just give it. What would the settings? Settings. Setting of setting. No constructors, nothing. That means we'll set the value by default. It creates. I want to set type. Actually, no, we already know it sets type to that. Then I don't simply make an assumption, will we? Type is null, right? For the default value, it's just going to be an uninitialized variable there. That means we need other functions. We need other functions to set data and type data. Let us, okay, set default. Let set the default value has to be stored. It has to be stored. So type default value G. So G is the abbreviation for. So you can say G or G for given or parameter. Okay. And then this is set default. Right, set default. It'll give us a type to be default value. Default value. And type, so for type default value. That's what set default value is. Then we check if the variable is equal to something that is in the table or if it has no value. How would we check if a type has value? If type, making sure of okay, so set default. We want to make sure not to break the abstraction here that providing basically a copy of set. You need to make it a mutex. You'll think of it as a mutex. Whenever it's actually set with a value, after that it can no longer be reset or given a new value unless that value is no longer held. So really, type data and such will be bool held, which will initialize to false. So in here, held false, right? Held is false, and that way, so when we set the default value, we set the default value, right? Then if that value is unset, if the value is not held, or basically not used, okay. Whenever we set a value, we set held to true. So it's true, it can no longer, we can drop, we can hold an item and drop an item. But we need to make sure that only the right agent hold the agent that drops an item needs to also hold item as well. So we could make a pointer, maybe like when the pointer is null and stuff not held, and then that pointer can point to the function that's using it. I'm thinking about it. For that setting, you can drop the setting or reset it. Held is false. So then, when the mutex, okay, let's use the real term mutex, and if it's held, that means you can't drop it anymore. Someone needs to be able to drop it so that you can reset the value, right? Someone needs to set it that way. So it's usually false. The mutex is false. It's not held. However, you can hold something. When you hold it, you need to be able to give the person who held it an ability to put it down. So you put the setting down. I need to see how that would work. You can't do unauthorized drop of a mutex. Unauthorized drop of a mutex is weird. Who gets to drop it? Okay, let's who can't. The person who can't drop it is the person who didn't hold it. How do we know who held it and who didn't? So that person is no longer using it. This really sounds like a dynamic allocation of memory. I like dynamic allocation. But first of all, you have to delete it. Only you have to delete it or manage it in some way. That's interesting. What if we do something like that? We have a persistent bool. We have a persistent bool, and that bool has to set a reference to the bool or like a pointer to the bool. So if you have the pointer, you can hand it to something else, and then that something else can walk around with it or have access to. No, then the pointer wouldn't signify access. If you have the pointer and it's private, it's not allowed. We need a function drop that we only give to, you know, I'm thinking. I don't want to start too much. I found the perfect idea. So, when we have a mutex that's held, we'll give an accessor to the person that wants to hold it. We'll like give them a new accessor, basically dynamically allocated, and that accessor is a class that has access to the private function, the private mutex. So through the accessor, we can hit like a public function, so the interface of accessor to set the mutex to hold it or drop it, and that once you're done with the accessor, you delete it, and now you no longer have access to that thing. The accessor will have a pointer to the setting that you want. So that's one thing. Then in code, you could say, oh, I want to see, wouldn't it be possible for someone to create their own accessor class and then set the pointer of the thing, of the actual setting, and then go ahead and, oh, that's true. At some point, someone's going to like look through the code and like use the interface to, yeah. I don't know. It doesn't seem like a bad idea. It doesn't seem like a bad idea. It's not like I can like restrict the users from doing something. Yeah. Yeah, that's it. Okay. So we have a mutex here, and I want to create a class accessor. And friend classes. Cool. This is node food. Okay, abstractions. Classes. Significance of concrete classes. Helper functions. Overloaded functions. Types and declarations. Pointers, arrays, and references. And obviously in this chapter, using the process instantiation. Chapter 17, construction cleanup, object overloading, class hierarchy, and segment information, class of a user-defined type, access, control, data and previous subsection provided for use of the object or data structure from explicitly with the code. Is the function. For example, any error causing basically down equal value must be caused by code in a member function. The present localization was completed before the program is even launched. The expression puts a general application. And must be affected by changes to its members. Class instruct, constructors, explicit constructors. Okay, what about in-class function definitions? We can define a named object as a constant or variable, immutable and mutable values. Since the precise terminology can be referring to some variables in concept of brief or static characters. However, that makes sense for native English because the concept is useful. It's embedded in the C++ type system. Use of immutable objects leads to more comprehensive code to ignore errors being found early and sometimes to improve performance. And these abilities are most useful possibly in multi-threaded programs. Functions of built-in functions be able to define functions that operate on const objects of user-defined classes. These spanning functions that use take constant member functions and logical functions mutable or to be mutable can be modified even in a class structure. Indirection. More complicated cases are often better handled by placing the pointing data on a separate object and accessing it indirectly. Extremely fast example depends on casting online. This does not require translatable to objects and systems. Self-reference. Okay, member access. Static members. Member type. A concrete class. I want to find where it uses the term from. Member functions. Helper functions. Typically, class has a number of functions associated with the need of the time. Then let's access the source. Negative ways of making available by including that file. Cleaning namespace. Overloaded objects. Which friend? Piece. Okay. Control F. Friend. Keyword friend. Okay, friend. So this is special operators. Subscripting function called. I want to see friend classes. Let's do increment and decrement. Allocation and deallocation. And a string class, a special operation, access to characters, representation, ancillary function. Using function. Member functions. So ancillary functions are there to complete class string. Helper functions, but what about friends? Ordinary member function declarations distinction. The function can access private parts within the scope of the class must be invoked on an object as of this pointer. Static. By declaring a non-member function a friend, you can give it the first property only. Friend is granted access to the implementation of the class just like a member function, but otherwise independent of that. For example, you could define an operator that multiplies a matrix by a vector. Naturally, vector and matrix have their respective representations. You don't really want to provide low-level access to functions every user. Avoidance to declare the operator is a friend of both. A friend declaration can be placed either in a private or public class. It does not matter where. Declare member function. The member function of one class can be the friend of another. Finding friend. Finding friends. A friend must be previously declared in an enclosing scope or defined in a non-class scope immediately enclosing the class that is declaring it to be a friend. Scopes outside the innermost enclosing namespace scope are not considered for a name if first declared as a friend. Consider a technical example. Friends and members. When should we use a friend function? What is a member function better? What about friend classes? Are we not allowed to do that? No? Friends and members. Operators that modify an operand are most likely required members. In most type conversions, with incomplete member over a friend taking the reference argument. The programmer may have preference for one class syntax over another. For example, most people can get the second rotation answers releasing an inverted matrix from M to the alternative this. However, on the other hand, if inverts M rather than producing a new matrix input, it should be amended. All other things considered equal. Implement direct access as member functions. It is not possible to know if someone someday with the conversion operator. The member function is calculates a clear to the user that the object may be modified. Expressions of the body. So that's one thing. So a handle. We want to create a setting handle. So public handle. I want to create handle. And this handle will first be created with this handle with nothing, right? This handle with nothing, or rather, can we set member functions of structs? Hold up. This is interesting. I want okay, so I have a class handle, and this handle, these default constructors are tripping me up. What do you mean? I need to set a way for the object to exist without its required values. This class needs the data. Who the hell wouldn't write the data that way? Okay. I guess it's pretty bad to do things immediately in the constructor, so we should have that. So we set the default, there's void set default type, or default set, right? Then there's also void value set, and that takes in a table of v underscore value. So we just set the values to a specific thing. This is the given value, given defaults. The values will be empty. We okay. Accessor is an awful name. Good, I wrote handle. Handle's much better. Description. Okay. So a handle is only for settings. So this handle is only for a setting or for any function handle on an object. So I want to write template type name object, right? A handle of an object will have an object reference. So you have to start it with an object reference, and all of these objects have to have a what is it? A function called set. A function, yeah, a function called set that doesn't return anything. However, that will have something like this, a parameter of a specific type. So really, the template type name type. So class handle, right, will take any object and then it wants and then with a template and a type. I need to read over how templates are used. I feel like I'm writing these wrong, aren't I? Um, though we have gotten a good idea. We make basically a setting as a class, a little object, and then you get a handle. The handle is useful for making sure that each object responsibly is the only one that's holding something. It may give the handle to somebody else, whatever it does. Or somebody might forge. It doesn't really matter to me. I don't care who forges the handle or who tries to use the code maliciously. I just want to have whatever um, like a basic just a functional system, a working system. I can worry about restricting or preventing people from using it the wrong way later. Right now, it's not really useful. So this is just work in progress code. I will look over this soon. Though creating the setting is important. It is quite important. Okay, I think I'll pause this. It's only been 1 hour. We got something done in the first hour. I realize I'm majority of programming time is just, uh, I'm just like, just looking over things. Let me think. Half of it is thinking. It's like, okay, I don't think it should be written this way or that way. Nerd. uh, oh, I did it again. I did it again. I'm going to close this recording, maybe cut it and put it in with something else. I need to go read a lot of thoughts. I'll come back later today. Signing off. Later to sign on soon.